Hello everyone, my name is Kamel, and in this video I'm gonna demonstrate the assignment 1 for Comp3122. So here we're just importing the library for NumPy, Pandas, and Matplotlib library, and we're reading the CSV file, and then we are taking the age column and convert it to a NumPy array. And here to do all these calculation, what I did is I converted the array into a list, and then here I'm storing the length of that array, and then we sort it. Then for calculation for the average, just the total number of the element for every value, and then we divide it by that length. And for the median, there's two cases: if it is the total number of the arrays is odd or even. So if it's odd, then it's just the middle element. If it's even, then we have two midpoints, and then we add them up and divide it by 2 to have the median. For the standard deviation, it's basically we're calculating every value inside the ages array, and we minus every value by the average, and then we square it. And after that, once we have all the values, we divide it by the length of the array, and the total number that we have now, we just get the root of it. For the minimum, because it's sorted array, then the minimum is the first element and the maximum is the last element. And here is the same thing, but we're using the NumPy library, which is the mean, median, the standard deviation, minimum, maximum, and the percentile. It's simple, it's easy, and as you can see here, we have the same numbers. For the question number 4, we are plotting a histogram. So we're taking the ages, the column of ages. I make it like 10 bins, and the color is sky blue, and the edges are black. I call it the age distribution by Kamel, and we have the X label here is age, and the Y label is count. And then we have all these average. We have the average, the median, and the percentile for 30 and 70%, as you can see here in these 4 lines. And for the question number 5, broadcasting, what I did here is I stored the heights in inches as a NumPy array, and the same thing for weight in pounds. Then we do a broadcasting, which just convert all these inches heights into meters by multiplying by 0.0254. Same thing for weight, and then we calculate the BMI is weight divided by square height. And we just do this formula, ages minus mean here, and just sort into ages z, and we printed out all the numbers. For question number 6, here we have, I'm storing the 6 column inside this variable after removing all the y spaces and the quotations. And as you can see here, I'm printed it, so it's just a clear male or female array. And then I'm basically masking is filtering. So here we have the adult mask, which basically age is over or equal to 18, which is an adult. Then you have female under 30, sex equal female, and age is under 30, and so on. So here we are doing the number of adults, which basically is just a sum of all adult masks. And the average BMI for adults here is, we're taking the mean, which is basically the average, and calculating that BMI for adult mask. And then the number for female under 30, just the sum of all the female under 30. And then we're doing the median BMI for females under 30, same thing. Then we're calculating the percentage of overweight people, which basically the sum of overweight mask divided by the length of BMI, and then we want the percentage, so we multiply by 100. And lastly, we want the average age for overweight people, which is also the same thing. And as you can see here, all the results. We are using a linear regression to predict a person's weight based on their age. So basically, the data is split into training and test. We are training the model on 80% of the data and tested it on 20%. So as you can see here, this is the real data, which is the real people with their weight and age. So here we have the weight, and here we have the age, and the red line is the model that we predict to be the relationship between age and weight over time. Thank you for watching.